My name is Katherine Davis. I'm an assistant professor in the Department of Chemistry at Emory University and a 2021 Beckman Young investigator. My lab works at the interface of chemistry, physics, and biology to study the structure and function of enzymes. As nature's catalysts, enzymes facilitate the reactions that sustain life. They're really the ultimate chemists with skills honed over millennia of evolution. It's therefore not too surprising that many enzymes efficiently perform reactions that we find challenging to accomplish synthetically. Enzymes that incorporate transition metal ions are particularly fascinating, as they can modulate the redox properties of their metallic cofactors in tandem with structural rearrangements to access greater chemical reaction space. A deeper understanding of these so-called metalloenzymes, along with the reactions they catalyze, has the potential to impact numerous scientific disciplines, from medicine to energy research, along with industrial applications in the production of essential commodities. In spite of this immense importance, we understand relatively little about the concerted atomic and electronic dynamics that facilitate metalloenzyme reactivity, due in part to technical limitations associated with the timescales on which these changes occur. Structural biology methods, for example, have historically been limited to static snapshots of reactant and product complexes, leaving us to fill in the gaps about as effectively as early photographers trying to determine whether horses lifted all four legs off the ground when galloping. Furthermore, these techniques provide little insight into the oxidation or spin state changes that accompany atomic motion in metalloenzymes. Supported by the Arnold and Mabel Beckman Foundation, my group has been developing a laser pump X-ray probe methodology for the simultaneous collection of crystallographic and spectroscopic data as a function of time to better understand metalloenzymes in action. In essence, we're collecting what I like to think of as augmented movies of enzyme turnover that depict changing three-dimensional structure alongside metallic cofactor electronics. Dr. Beckman understood that transformative science often begins with new tools, and his inventions from the pH meter to the DU spectrophotometer changed the face of experimental chemistry. In the spirit of Dr. Beckman's vision to enable discovery by inventing better ways to observe the natural world, our goal is to make time-resolved techniques more accessible and broadly useful for the study of metalloenzymes. Toward that end, we've demonstrated the feasibility of collecting X-ray emission data on single protein crystals at more widely available synchrotron sources and developed novel photo-triggering methods to reproducibly initiate catalysis in health-relevant enzymes that are not naturally light-activated. Fittingly, Dr. Beckman's invention of the spectrophotometer remains central to my group's ability to develop these methods today. Beyond his legacy as an inventor, Dr. Beckman also invested in people, supporting young researchers through philanthropic programs that foster creativity and bold thinking. I was fortunate to receive such support as a Beckman postdoctoral fellow, an experience that shaped my approach to both research and mentorship. Reflecting that commitment, my group has engaged in outreach efforts that introduce elementary and high school students to the excitement of chemistry and the possibilities of discovery, supported by a Beckman Family Awardee Community Support Grant. I'm deeply grateful to the Arnold and Mabel Beckman Foundation for making both our science and outreach efforts possible, and for continuing to champion the kind of science that asks unconventional questions and builds the tools to answer them. We're just beginning to explore the choreography of metalloenzymes, how they move, change, and react in real time. The more we understand, the more we can imagine new treatments, new catalysts, new ways to think about chemistry itself. The Beckman Young Investigator Award came at a pivotal moment in my independent career. It allowed me to pursue a high-risk, high-reward project that crossed disciplinary boundaries and connected me with a dynamic community of scientists whose support continues to shape my growth as both a researcher and a leader.